Hey everybody, the purpose of this video is to remind you of the informal definition of a limit and to explain to you how it differs from finding a function value, and then to show how to find limits by inspection. So we're calling this limits by inspection, or how to look at a graph. So first of all, the informal definition of a limit is the limit is the value an output approaches as an input approaches a number. So as x gets really close to something, or h gets really close to something, or whatever variable you're dealing with gets really close to a value without actually equaling it, the thing that you're taking the limit of, we're asking what that gets really close to. So we've already sort of talked about limits a little bit with the idea of slope of a local linearization. So I'm going to talk about these two. These are what are called slope limits. The input is x approaching a number, or the change in x, which is h, approaching 0, getting really close to 0. The output is the thing that's next to these limits. And if you remember, these outputs came from slopes. This was the slope of two distinct points, x and a. This is the same definition, just phrased in a different way. So for these limits, the input is getting really close to an x value, and the output is the number that the slope of the local linearization is getting extraordinarily close to. That's what you've been sort of working with up to this point. But you can also ask questions about limits that simply approach an x value and ask what the y value of the function does. It doesn't have to be a slope. You can ask about the y value. So this would be what an input getting close to a number, a, and the output getting very close to the y value of a function. Okay, so how does it look different when you're trying to find a limit or a function value? So let's look at a graph. So when you look at this graph, I'm going to ask several questions about this graph, and I'll pop back onto your screen for a second. So when I'm looking for function values, what I'm really looking for is the point on the graph. So I want to know what the y value actually is at that point. So if I'm looking at something like f of 2, if I look at the graph where x equals 2 right here. Now, notice the actual point that has an x value of 2 is right here. So that means the f of 2 would be 1. This stuff down here, irrelevant. Doesn't matter at all when you're talking about a function value. You just want to know where the point actually is. So f of negative 2, if you look at the x value of negative 2, there's a point at 4. F of 0, there's a point at 0. F of 5, there's a point at negative 2. Even though there's not an emphasis on the point, there is a point there. So function values give the actual y value at that place. Now, limits are a little bit different. Whenever you're looking at a limit, you're trying to figure out what the y values are getting really close to, rather than what they actually are. So if I were to look at, say, the limit as x approaches 0 of f of x, this is asking, as I walk along the graph, coming from the left and coming from the right, what do the y values get really close to as I get close to 0? So from the left, you can see my y values are getting closer to 0, and from the right, also closer to 0. So we would say the limit as x approaches 0 of f of x is 0. Now if you look at 5, walking from the left, the y values are getting closer and closer and closer to negative 2, and from the right, the y values are getting closer and closer to negative 2. Now you may look at those and go, how is that any different than the actual function value? Limit as x approaches 2 and negative 2 on this graph, things are happening that are wildly different from the function value at each of these points. So we're going to talk a little about how limits apply there. First of all, you need to know a distinction. And the distinction that we need is between a two-sided limit and a one-sided limit. So up to this point, I've been saying, hey, a two-sided limit, what is the y value that the function approaches as x gets close to a number from the left and the right? So you have to look at it from both sides. A one-sided limit is what the y value approaches as you get closer to the x from the left or the right, not both. So if I were to go back to this graph, and I were to look at this again, as x approaches negative 2 from the left, here's negative 2, right here. I want to come at it from the left, which means I want to start at x values over here on the graph. So as I'm walking towards -2 from the left, you see that the y values are getting closer and closer to -1. Now notice that has nothing to do with the actual point, which was f of -2, which was up here at 4. All I cared about is what the y values themselves are getting really close to, and from the left, they're getting close to -1. Now, from the right, which is this, if I walk at -2 from the right, you see the y values are getting closer and closer and closer to 2. So the limit as x approaches -2 from the left, which is symbolized like this. It looks like a negative in the power, means it's from the left. That would be -1. And the limit as x approaches 2 from the right, which is symbolized with a little plus in the power, would be 2. Now, two-sided limits. The limit as x approaches a value from both sides. We talked about 0, we talked about 5. Those were both easy because they approach the same number from both sides. But 2 and -2 and 2, both approach different numbers from either side. So I can say what happens from the left and what happens from the right, but what would happen when I'm talking about from both sides, the two-sided limit? Well, there's a rule. And the rule is, a two-sided limit can fail to exist if the limit from the left and the limit from the right don't equal the same number. In other words, boom, here's the mathematical version of it right here. If the limit as x approaches a from the right of f of x doesn't equal the limit as x approaches a from the left of f of x, then the limit from both sides as x approaches a does not exist. So if you say we had something like we had in the last slide for 2 and for -2, you look at 2 from the left, the limit would be -2. From the right, the limit would be -3. Those don't equal each other, so we would say the limit as x approaches 2 from both sides does not exist. Same thing with the limit as x approaches -2. From the left, the limit is -1. From the right, the limit is 2. Those don't equal each other, so the two-sided limit does not exist. So here's what you need to know. First of all, a limit is a value that a function's output gets really close to but does not equal as x gets really close to a number. So that's the distinction between f of a number and the limit as x approaches a number. And then two-sided limits, one-sided limits. One-sided limits mean as you're coming from one direction or the other. Two-sided limits mean you're coming from both directions. And then, if the one-sided limits do not equal each other, from the left, from the right, may have gotten those directions confused, then the two-sided limit does not exist.